Okay, as I look around the room, it looks like everybody pretty much did this correctly. I'm going to go ahead and draw them here for the purpose of the video for those at home today that couldn't join us. So when we look at nitrogen, we have this triple bond. Each nitrogen is the same. Each nitrogen has one attached atom, the other nitrogen, and one lone pair. So the steric number for both nitrogens is 2. So each of them forms an sp hybrid. That means that each nitrogen can make one sigma bond with its hybrid and 2 pi's. So we get 1 sigma and 1 pi. And then when we think about this, the shape, because this is just a 2 nuclei molecule, is linear. Anytime you only have 2 nuclei or 2 atoms, you're going to have a linear molecule. So that doesn't really fit in our discussion so much. 1 pi, 2 pi's. Yeah, 1 sigma and 2 pi's because it's a triple total. So 1 and 2 is 3, triple bond. Okay, now the CO2, this is a little bit different. Here we have 3 nuclei, and when we look at our Lewis dot structure, the carbon in the middle has 2 attached atoms and no lone pairs, so carbon has a steric number equal to 2. So carbon makes an sp hybrid. It means that it has 2 unhybridized p orbitals. Now the oxygens are different. They have 1 attached atoms and 2 lone pairs, so their steric number is 3, so they make an sp2 hybrid. So oxygen's sp2 hybrid makes a sigma bond here with carbon's sp hybrid, and then oxygen's 1 unhybridized p makes a pi bond with carbon's unhybridized p. So each bond area we get a sigma and a pi. And over here I have a sigma and a pi. So the whole molecule is going to be linear because the central atom has sp hybrids. So this whole thing is linear. Now if we look at carbon monoxide, it's just like nitrogen. The only difference is we have a 2 different nuclei molecule, a heteronuclear molecule. But again, carbon has a steric number of 2, 1 attached atom and 1 lone pair, so it's an sp hybrid. And oxygen has a steric number of 2, 1 attached atom, 1 lone pair, so it's an sp hybrid. So each of these nuclei has 2 unhybridized p orbitals, so those 2 unhybridized p's make the 2 pi bonds. So this triple bond is a sigma and 2 pi's. So when we look at valence bond theory, it tells us that the sigma bonds determine the framework or the shape, and that comes from the hybrid orbitals. Hybrid orbitals are used to determine the shape and hold the lone pair. The number of hybrids is equal to your steric number, your electron domains, attached atoms plus lone pair. Anytime we have a double bond, it's a sigma and a pi, and anytime we have a triple bond, we get a sigma and 2 pi's. Carbon monoxide, carbon has 4 valence electrons, oxygen has 6. Okay, you don't have enough electrons for it to be just a double bond. Okay, so let's go ahead and stop here and we'll take our second break for the evening. And for those of you watching these videos, this is the end of the videos for the evening.